I can pause it.
Maybe not, it's just a
I've
carrier,
never seen it going out place, but I don't know.
but it's just a carrier.
But it's just a
This
carrier.
is the biceps breaker.
But they will always travel together, these little H's over here. Does that make sense? Yes?
Mhm.
Okay, so now we're gonna take these 3 carbon chains that are called
Pyruvic.
pyruvic acid, and we're gonna put them into the citric acid cycle.
Do you want me to reset what you did?
If you want, or you can leave it up.
We'll leave it
I'll
up.
see a picture.
Yeah.
Okay. So we're gonna start with pyruvic acid. Now this is gonna all happen in the mitochondria, because this is assuming that we have oxygen,
Oxygen.
right? Because if we don't have oxygen, what happens?
Goes back to lactic acid.
Right, and goes to,
Liver.
that's right. Good job. There we go. Okay, pyruvic acid, right there. So it's a 3 carbon chain that we got all the way from over here, right? So you come over here, pyruvic acid loses 1 carbon and becomes something called acetyl-CoA, right here. This is a 2 carbon little mini chain. Okay?
So you lose one and become 2.
You lose 1, you become 2. This extra one that leaves becomes a carbon dioxide molecule. Every time you kick off a carbon, you make carbon dioxide. So that's why whenever we were doing digestion or what was it, or respiration that we were doing, and I said, you know, that's your byproduct of all of your cell metabolism, because it's going to keep getting kicked out. Carbon dioxide is always getting kicked out of the system. And this is how it's going.
A little heavier than I thought.
Oh man, this rules. So now
Not as light as I was this morning.
it happens to me every day. No problem. So now you have acetyl-CoA that's 2 carbons long, right? We kicked off a carbon to make carbon dioxide. Oh, I also forgot to put. But every time you kick off a carbon, you also have to get rid of hydrogens. So again, NADH came in. NAD came in and became NADH plus H, which I forgot to write over here. I'll write it back in a minute. Okay? We take our little 2 carbon, and we have something called coenzyme A. And all coenzyme A does is take this little 2 carbon molecule and tack it onto an already existing 4 carbon molecule. And we'll show you how we get that in just a second, but it's already there. So we take 2 plus 4, and we get this, a 6 carbon chain.
So does it also hack off the 3rd carbon? I mean, up there?
This one right here?
Yeah.
Yes, this one gets kicked off to become carbon dioxide.
The coenzyme A does that?
It doesn't have to do that. All coenzyme A does is carry this little 2 molecule combined with this.
It's the mixing of the oxygen, right? That kicks it off.
How come it has it in the step above that?
That's going to
Where you
grab
have
the
it.
Right.
Is that right? Because it found oxygen now, and it kicked it off.
I don't know if that's the reason why it does it,
But who cares?
but it does do it.
So it has nothing to do with bringing the H over to the NID, the NAD?
No, the coenzyme A doesn't do that. The NAD just picks up the H's because that's
Their own job. And
That's
you
what it's
float around
naturally
H's,
for.
you're getting on the
But it
bus.
doesn't have anything to do with taking off the 3rd carbon?
well. Every time a carbon gets kicked off, you're going to liberate hydrogen, just like you did over here. Whenever we split the carbons, you liberated hydrogen. Over here, you're going to liberate hydrogen as well.
I'm just wondering why it has it in this step here if it doesn't participate in,
Probably because it all happens at the same time, but not
because they have
necessarily.
it here and up here. They have this.
Oh, it's
4
showing there that coenzyme A is just leaving because since it's just an enzyme,
Oh,
it
it's
just
leaving.
it just takes place in this one little piece and then it goes back and it's recycled to the center.
So it doesn't have anything to do up here, it has something to do with adding 4 carbon to this 2 carbon thing?
Right, because this is going to become this, right? Pyruvic acid becomes acetyl-CoA when I lose a C. When I lose a carbon. Once I've lost that carbon, coenzyme A will come in and bind that 2 carbon molecule to this 4 carbon molecule.
So what liberates the carbon in the hydrogen from the
No, I'm not
hydrochloric
sure.
acid?
Like she was saying, maybe it's the attraction to oxygen because now you have oxygen involved. I'm not sure why it pops off the way it does. But I wish I was cooler and wiser.
What does he want to see